So this is lesson 7.5a, elementary algebra, equations involving rational expressions. Okay, the key word in that title is equations. So that means rather than just simplifying these problems, we're going to actually solve them, find out what the value of x is as we do these. So, first step when it comes to doing these kind of problems is finding the LCD, finding the least common denominator. So I'm going to start with example 1. So it says solve for x. Alright, so again, first step, find the LCD, least common denominator. And if you remember, the least common denominator is what is the smallest, the least number that is common to all three of these. What is the smallest number that 3, 2, and 2 will go into? So if you look at that, it would be 6, because 3 goes into 6 and 2 goes into 6. Okay? And it doesn't matter. I mean, you could use a number bigger than 6. I mean, you could say, why can't I use 12? 3 goes into 12, and 2 goes into 12, and 2 goes into 12. That's fine. You could do that. But it's simpler if you find the least. You just are dealing with smaller numbers and you don't have to reduce. So anyway, you find the least common denominator. In this case, it's 6. And you multiply the entire equation by 6. Now, some people write it that way. Some people write it this way. Doesn't really matter. As long as you multiply each term by 6, you're doing good. Alright, so 6 times this one is 6x over 3. 6 times this. 6 times the other one. And you get that. Alright, so notice what happens here. Your fractions disappeared. So that's what happens when you find the least common denominator and multiply all of the terms of the equation by that least common denominator. The fractions disappear. So that's pretty much all you did there. And then you solve for x. So in this case, we are going to take and subtract 15 from both sides. And we get 2x equals negative 12. Divide by 2, divide by 2, x equals negative 6. Okay? So once you get there, and this is a key thing about these kind of problems, is you have to check. Now, so many times you're not going to want to check, but when you don't check, sometimes you find out that there's a screw up here. So let's take this negative 6 and put it back in the original equation. So the original equation was this. So let's put negative 6 in for x. Okay. So negative 6 over 3 is negative 2 plus 5 halves equals 1 half. Common denominators. Negative 5 plus 5, or negative 4 plus 5 is 1 over 2, and that works. So this is a true statement. Now we're going to do some where that answer we get doesn't work. So later on I'll show you how to do that. So it is important to do the checking on these. So please remember to do that. Alright, example 2. Alright, so again, first step is find the common denominator, the least common denominator that both x minus 1 and 5 will go into. So the key thing about finding the least common denominator when you've got things like this is you just put them both together. And you're usually okay. So when you got something like just a number and then you've got an x minus 1, so you've got a variable in there, usually the case is that ends up being your LCD. So we take 5 times x minus 1 and multiply it by 3 over x minus 1. And then we take the 5 times x minus 1 and multiply it by that. And notice what we can do here. Cancel that and cancel that and that. So we canceled the denominators, which means we have 5 times 3, and we have x minus 1 times 3. Or we can put the 3 here. That's usually easier. We do the distributive property. Sorry about that pounding next door. Add 3 to both sides. We get 18 equals 3x. Divide by 3, divide by 3. And 6 equals x. Okay? Now we take this and it goes back in the original. So we take 3 over, and we're going to put 6 in for x. And what do we get here? 3 over 6 minus 1. That's a true statement, so x equals 6 is correct. Okay, so let's go ahead and do example 3. And there it is. So again, we're looking for least common denominators. So let's make this one a fraction. So we're looking at 1 x squared into x. So when you have two bits like this that are the same, an x and an x squared, you pick the bigger one. And we also look at the number that's down here. Well, it's a 1, so it doesn't really matter. So we look at the x squared and the x, so the x squared becomes my LCD. Okay, then I just multiply that, that, and that. And then I cancel. That x squared with that x squared. That x with one of these. I'm left with okay. This right here tells me I'm going to have two answers. So, bring the 5x over. Get everything over there, set it equal to 0 since I have an x squared. Okay, let's move everything up. As we're looking at this, divide this up into two binomials because that tells me I'm going to have two answers. So I've got an x and a 3 and a 2. And which one's positive? They're both negative. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So x minus 3 equals 0. And x minus 2 equals 0. So x equals 3. And x equals 2. Now what you've got to do, which let me see if I can move my original, get my original problem back here, which is right here. I need to plug in 3 in for x, and then once I'm done, I plug 2 in. I've got to do it twice because I have two answers. So 1 plus 6 over 3 squared equals 5 over 3. So I'm trying to see if this is going to equal 5/3. So 1 plus 6 over 9, and 6/9 reduces to 2/3, and 1 can be changed to 3 over 3. And notice 3 plus 2 is 5. And those work. Okay, so this one works. Alright, let's try the number 2. So 1 plus 6 over 2 squared equals 5 over 2. Okay, so that's 3 halves. And we'll change 1 to 2 over 2 so that I can add these. and those are equal as well. So 2 works also. Alright, so that's example 3. Now let's do one. It's going to be a little bit trickier by looking at example 4, and again, they always do. They get trickier and trickier as we go down the line here, but let's see if we can do this in baby steps so you can get it. So remember on the last one, when I said if we have a number and then a letter, it's usually this and this combined, and it's the same as the case here. So this and this are the same, so those are common. It's this one that's different. So our common denominator is the 2 and our x minus 3. Now we don't have to distribute that, we just write it like that. We don't have to distribute the 2. So we're going to multiply this times this whole thing. And we're just going to write it stuck together. And I'll put that in parentheses. And then 2 times x minus 3 times 3 over 2 equals 2 times x minus 3 times 3 over x minus 3. Okay, then I go back and cancel. That with that, that with that, and that with that. So notice, all of my fractions went away. So what am I left with here? And I'm left with, move the 3 in front, and I'm left with 6 here. So my fractions are gone. I'm going to distribute that. Add those. Add 9 to both sides. Divide by 5. And what's my x equal to? 3. Now I know I'm okay with one answer because I don't have any x squareds up here. So I know I only get one answer. Okay, so now we are going to put this answer into that. So let's get rid of, alright, so we have x equals 3. So let's get rid of all of this stuff. And we got x equals 3. So let's put that 3 in. Alright, the book goes all the way through and solves this, but one of the things I want you to notice is right here and right there. What happens to my denominator? Whenever your denominator is 0, the equation is impossible to do. It's undefined. There is no answer. So remember this handy dandy little symbol? That's what you would write for this problem. Okay? They went through and did the whole problem to check it. You don't have to do that. As soon as you end up with a 0 in the denominator, you know you're done. Okay? And when this happens, it is called an extraneous root. Okay? So an extraneous root means that we get a value for x. Even though we did the math right, we get a value of x that does not work. And usually that means the 0 is in the denominator. And you just get up. No, the answer is not 0. The answer is undefined. This right here. There is no answer, and 0 would be an answer. Okay, so I will stop here and finish up. We'll do example 6 and some set problems for 7.5 on the next video.